All right, moving on. In this lesson, we are going to work a little bit more with limits, okay? So first of all, we're going to solve some limits graphically, numerically, and algebraically. So here's one limit that I want you to be able to find. It's the limit as x approaches 1 of the function x cubed minus 1 over x minus 1. You can go ahead and get that onto your graphing calculator if you want. I do want you to notice that when you get that onto your graphing calculator, you're going to need to put the denominator in parentheses, the numerator in parentheses, and the denominator in parentheses. I'm going to go ahead and put this in here so that you can see this quick. So take just a second to open, but make sure that you, in your y1, put your numerator in parentheses and your denominator in parentheses, or it will not graph right. So I'm going to go ahead and do this here quick. All right, I'll go to y equals, and I'll do the quantity x cubed minus 1 divided by the quantity x minus 1. All right, and go ahead and hit graph. So this is what it looks like, and according to the graph, it does not look like we have any points of discontinuity at all, and we don't have any jump discontinuity, which is where, like, jump discontinuity would be like that, where it, like, you know, you have to, your y values are not approaching the same number, okay? Anyways, if I look at where my x value is 1, right here is where my x value is 1 on this curve. As I look at that, it does look like my y values, as I move in here, my y values are at about 3 right there, okay? So it looks like that curve is approaching 3 when x is approaching 2. And it doesn't matter if I approach 2 from the right side or if I approach 2 from the left side, my y values at that point right there are at about 3. Okay, so that's one thing you can do is to solve it graphically and look at it that way. The other thing you can do is to solve it numerically, which is with a table. Okay, what you want to do is you want to set your table up so that your x values are getting closer and closer and closer to the point that you want to look at. And you know what? I'm sorry. On this last example, I was supposed to be looking at when x is approaching 1, not 2. My x value was supposed to approach 1. Okay, so let's go back to our calculator. Sorry. And when x is approaching 1, that's this point right here. Oh, maybe I did do that. It is at 3. Did I do that? Did I said 2? I don't know. Anyways, when x is approaching 1, it is at 3. All right, here we go. Now we want to do when our x values approach 1. When we look at our table here, and I'll show you how to get this table here in a minute, but as you can see, as your x values are getting closer and closer to 1 from the positive side and negative sides, both of those, your y values are getting closer and closer and closer to 3. I do want you to notice that you have an error right there. That's because you have a hole, and I'll show you why you have the hole. But since your y values are approaching the same number, whether you move it from either side of that, there actually is a limit, okay? Even though it's just continuous there is a limit. And, oops, I was going to show you how to get that on your calculators, okay? On your calculators, here's what you do. To look at your table, obviously, you can go ahead and hit table right here, and it'll pop those numbers up. The problem is you need smaller and smaller increments. Right now, your increments are going from 0 to 1. So you want to change those increments so that they're much smaller. I would do something like 0.001 maybe. And then we're going to start our table at 1 just so that you can scroll up or down from the value that you want to find. If you were trying to do it as x is approaching 2, I would put 2 there. If you were doing it as x is approaching 3, put 3 there. But we're trying to do it as x approaches 1, so I'm going to do 1. And then I'll go back to my table, and you can see what's happening there as you do that, okay? Something does not look right. I'm going to do this. I don't know what I just did. Table start, oh, I put in the wrong number, that's why. Table start is 1. this should be 0.001. Sorry, I mixed those two up. And now we're going to go back to our table. And now you can see it, okay? As x is getting closer and closer to 1 from either side, your y values are getting closer and closer and closer to 3, okay? So that kind of tells you what is happening there. And then we will look at it algebraically as well. In order to look at this algebraically, we have to solve this with the sum and difference of cubes. If you look at your note sheet, at the top of the note sheet is the formula to factor the sum and difference of cubes. I just want you to notice that this is like x cubed minus 1 cubed up here. So that means that your a is x and that your b is 1. Okay, when you follow the formula, then you're going to factor that, and it goes a minus b, and then this is b squared plus ab. Sorry, this is a squared. Oh my gosh, you guys. This is a squared plus ab plus b squared. Okay, what I want you to notice is this sign is always the same as this. This sign is opposite of that, and this sign is always positive every single time. Okay? Since a was x, a squared or x squared is obviously x squared. A is x, b is 1, so a times b is x times 1, which is just x. Okay, I think you guys can do that. Anyways, here I'm at. Here's where I'm at. So I factor the top out, and now what happens is these x's cancel. By the way, I couldn't just take 1 and plug it in from the beginning, because if I did that, I'd have 1 minus 1, which is 0 in the denominator, and you can't do that. But now that I have simplified this and factored it how I needed to factor it, and now I have the limit as x approaches 1 of x squared plus x plus 1. Now I can go ahead and plug my x value of 1 in, and I am not going to get an illegal operation. So I can plug those x values in, and so I get 1 squared plus 1, which I also get to be 3. Okay, so my limit does approach 3. All right, sometimes you can't do a substitution, and you have to use these fancy rules, and we'll talk about them as we kind of use them. I think you can read them and sort of figure them out. But first of all, I'm giving you this quantity at the beginning that will really help you. Okay, just know that the limit as x approaches 0 of sine x over x is 1. I'm telling you that answer from the beginning. Okay, so we know that, and what we're going to do is we're going to use our exponent rules to solve this problem right here. I want you to notice that I can't plug 0 in from the beginning. If I plug 0 in, I'll have 0 in the denominator. So I need to use my limit rules and my exponent rules and my addition and subtraction and quotient and all kinds of rules, okay? So what I want you to notice on this is that you're basically going to use this rule right here, okay? That the limit of two things added together is the limit of each of them separately. So first of all, I want you to think about this. I can break this fraction up into x over x and sine x over x, just so that you can see that. And if I take the limit of that whole thing, it's the same as doing the limit of each one of them separately. Okay? So here's the deal. X over x is just 1. Okay, so the limit as x approaches 0, I don't even have a number to plug in for 0. So this is just 1. Over here, I gave you this at the beginning of the problem. I told you that the limit as x approaches 0 of sine x over x is 1. And so the answer to this problem is 1 plus 1, which is 2. All right. In this next one, you have to remember just a little bit of trig, just so that you can kind of picture this. If you remember, there was this famous identity called sine squared plus cosine squared was 1, which of course you can manipulate that. Like I can move this cosine to the other side, and I would get sine squared is 1 minus cosine squared. Okay, so you kind of need to know that. This is substitution here. This is going to be replaced with sine squared because 1 minus cosine squared is sine squared. So now where I'm at is this. Okay. And this is really, when you square something, it's really like multiplying it by itself. So this is really the same as this. Sine x over x times sine x over x. Squaring something is really like multiplying it by itself. Okay, and now you can use the product rule, where if you're finding the limit of two quantities multiplied together, you're really finding the limit of each one of them separately. Okay, so this will be the limit as x approaches 0 of sine x over x times, again, the limit as x approaches 0 of sine x over x. Okay? When you're finding the limit of two quantities multiplied together, find the limit of each one of them, and then multiply your answers. Okay? I gave you at the very beginning that that was 1. This is the same thing. That's 1. I'm going to multiply them. 1 times 1 is 1. All right. And now, again, we're going to use our exponent rules in combination with our limit rules here. And we're going to kind of simplify this. So this would be the limit as x approaches 0. This is the cube root of a fraction. And I can really make that a cube root of one big thing. Like that. Okay. And then you're going to use your root rule of this, and which is this guy right here. If you can kind of, I know that's hard to see up here, but you can look at your note sheet. So what this is, it's really the cube root then of the limit as x approaches 0 of sine x over x. Okay, this quantity again I gave you at the beginning, and it's 1. So what you really have is the cube root of 1. And the cube root of 1, what times what makes 1? Is just 1. Okay, so that's those. Then you've got some where you really can use substitution from the beginning. Okay, I can go ahead and I can plug this x value in. Plugging this x value in here is not illegal. Plugging it in here is not illegal. Plugging it in here is not illegal. So that's what I'm going to do. And I will be able to find some things. Okay, so you need to remember just a tiny little bit of trig and a tiny little bit of some exponent rules. I'm plugging 0 in. All right. First of all, this is what I want you to know. Anything to the 0 power is 1. Okay? Then you need to think about your unit circle. 0 degrees is right over here. If you think about your unit circle, you remember 0 degrees is right over here. This is the coordinate 1, 0, if you remember. Sine is your y value. So sine at 0 is your y value at 0. And your y value at 0 is 0. Okay? Your cosine value at 0, cosine is your x value. So your x value at 0 is 1, but it's cosine squared, so it'll be 1 squared. So you'll have 1 over 1 squared, which is obviously just 1. All right, again, I can take a number here and I can just plug it in. It's not going to be illegal for me to do that. I'm not going to have zeros in the denominator or anything that I can't do. So the limit as that approaches 16 would be the square root of 16 over log base 2 of 16. Well, clearly the square root of 16 is 4. Okay, the bottom part you might not know what to do. You can use your calculator if you want and figure that out. Or you can realize that log base 2 of 16 is something. And what that means is 2 to some power is 16. Well, it's 2 to the 4th power, that's 16. So this is 4, and I get 4 over 4, which is 1. Okay, one more of these. Here we go. Again, It's okay for me to plug 0 in here. I'm not getting illegal answers. So this becomes e to the 0 minus tangent at 0 over cosine squared at 0. Okay? Again, I don't really care what you have right here. Anything to the 0 power is 1. Let's think about our unit circle again. Okay, here's where the 0 is again. Oops, your coordinate is at 1, 0. Okay, here we go. Tangent is y over x. So 0 over 1 at 0 degrees is 0. Cosine at 0 is your x value. Your x value is 1. So I have 1 over 1 squared, which again is 1. Okay, so that is that lesson.